Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 312, I continue my conversation with video guru Florian Friedrich about high dynamic range. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded July 14th, 2016. Episode 312, Calibrating HDR, Part 2. This episode of Home Theater Geeks is brought to you by Corning. Corning's incredibly durable Thunderbolt and USB 3-point optical cables are longer, thinner, lighter, and stronger. Go to corning.com/twit to save up to $130 on their superior Thunderbolt optical cables. And by Epson's new EcoTank printers. With Epson's line of SuperTank all-in-one printers, you can print thousands of documents without running out of ink. EcoTank is loaded and ready to print when you are. Visit epson.com/EcoTank to find out more. Hey there, Scott Wilkinson here, the home theater geek and editor of avsforum.com. This week, I'm happy to have Florian Friedrich back with me for part 2 of our discussion of high dynamic range, or HDR as we will call it. Hey, Florian, welcome back.
Hi, Scott. It's good to see you again.
Good to see you too. Thank you so much for being here for round 2 and also for staying up late one more night. You're in Germany, and so it's quite a bit later there, but I sure do appreciate that.
Thanks.
Before we get started, I want to make sure everybody knows, those who are watching live at live.twit.tv can join the chat room there, or they can go to irc.twit.tv. And you can post questions as we go, and I'll pass along as many as I can. It always helps if you put my screen name somewhere in your message, which is, my screen name is Scott Wilkinson, my name, no dots or dashes or spaces. And that way it'll show up on in a different color on my screen, and my eye will be more easily drawn to it. So first thing, Florian, I want to clear up a little confusion that we had last week. Which has been cleared up on some of the comments on YouTube and elsewhere on AVS. But that was your reference to a backlight of 5 nits. And I sort of said, what? And then we moved on. But I think this was more a language problem than anything else. What did you really mean by that?
A bias light. So it was a
light.
Yeah, it's like the backlight of the TV, behind the TV. So,
yes,
yeah.
yes. But you understand the confusion, right? Because
of course,
in an LCD TV, there is a backlight within the TV that sends light through the LCD panel, and that's how you get your light. But you're talking about a backlight, and that's also a reasonable word for it, which is very confusing. But you're talking about the light that you put behind the entire TV that gives you a little bit of ambient light in the room, which we, in America anyway, call a bias light, because it biases the dynamic range of your eyes to kind of match what the TV is doing. Have I got that right?
Yeah, and it makes a lot of sense, yes. I'm using the term bias light normally as well. But in this case, I guess it was after the soccer game and very, very late at night. I don't know.
Yeah. So. Well, okay. Well, then let me ask you about that point before we move on, which is, you said something about a 5-nit bias light. Now, 5 nits is not very much. Normally, when I can talk about bias lights, the general recommendation I've heard is 10%. The bias light should only be as bright as 10% of the peak luminance or peak brightness of the display, which in standard dynamic range, which we will assume that the peak brightness of a standard dynamic range display is 100 nits, then the bias light should be 10 nits. But on an HDR set that might have a maximum luminance of 1,000 nits, shouldn't the bias light be 100 nits, not 5?
Exactly. So the 10% maximum for the bias light makes a lot of sense. And I'm saying maximum because the bias light is not a uniform light. So there is a darker and a brighter spot behind the TV. You won't get it uniform in this sense. So normally it would be like 10% peak brightness of the TV. So let's say the TV has 1,000 nit, and then you would go up to 100 nit. My personal environment right now for grading is 50 nit. It works pretty well, but it's far more than what the ITU BT 2100 is recommending. And that was my major point. Like 5 nits as a bias light, you tend to grade a lot darker, a lot dimmer when you have such a low bias light. So it makes sense to increase the amount of light behind the TV.
So it's the BT 2100, the ITU recommendation that we talked about a little bit last week, that's saying you should use a bias light of 5 nits, really?
For critical mastering. Yes, yeah. Exactly. But basically, you should put a backlight, bias light. You should put a bias light behind the TV, even in your living room condition. That
even with a lot of other ambient light in the room.
Oh, ideally, you don't have any light reflecting off the screen. So you don't want to have lights behind your seating position or bright objects behind your seating position, because you don't want to see reflections. What you want to avoid is that you're sitting in a completely dark room when the TV is like 1,000 nits bright, 1,000 nit peak brightness, that actually could hurt your eyes a little bit. So I don't like the situation where you're sitting in front of a TV that could go up to 1,000 nits and everything else is completely dark. Therefore, again, it makes sense to have some bias light, but this bias light should not be at 5 nits. 50 or 100 nit looks a lot more appropriate.
This also brings up the question of those of us on AVS Forum who are videophiles. We will probably tend to watch in darkened rooms. A lot of people have projectors too, and for that it's critical. But even for those who have TVs, we, those of us who are video enthusiasts, will tend to watch in a darkened room. But in the general public, that's pretty rare. Most of the time people watch with ambient light on, which is one reason why 1,000 nit TVs, are a good thing in that environment. So I guess you probably don't need a bias light if you're watching, even if you don't have like a lamp right behind you that's going to reflect right off the TV, or a door or a window, and you're watching during the day. But you have, lights on elsewhere in the room. Maybe the kids are playing in the corner, or grandma's doing her sewing or whatever. A lot of people watch TV with the lights on. Probably not you, though, right?
Actually, I have 2 kids, and these 2 kids, they actually need some light because I don't want to have them stumbling around in the room.
Very good.
So we need to be aware, as much as there is a enthusiastic approach where you want to avoid all sorts of ambient light. We need to be aware that ambient light is necessary and is existing in regular room conditions. So controlling this ambient light is actually the key. For example, things that you could do is making the first 30% of the viewing distance, like you're sitting 3 meters away, and then make the first 1 meter from the TV to your seating position, make that as dim as possible. That's essentially what happens in a projection environment. So if you are projecting on a screen, you need to make sure that no objects are bouncing off light and bouncing it back to the screen and decrease the contrast ratio. Now with TVs, the situation is a little bit different, of course, because there you want to make sure that you don't have direct reflections. And that would be light behind your seating position or bright objects at the area where you sit.
I mean, certainly, if you have bright objects right behind you, that is, or either a reflective object like a mirror or a shiny metal thing, or a light directly behind you, that's going to reflect right off the screen. And most screens are very reflective, so that's going to really be distracting, don't you think?
Exactly. So, but if you use a backlight, that's a point that I wanted to make. If you use a backlight, you should make sure that the color of the backlight is very similar to the white point of the TV.
Very important.
Ideally, you would have a D65 backlight, a 6,500 Kelvin backlight. Just recently, I bought a LED light at the department store. And it said 6,500 Kelvin.
Yep.
But essentially what I measured was 22,000 Kelvin. So
wow.
Yeah,
wow.
so,
well, you can't, truth in advertising didn't work there, that's for sure.
Yeah. So the general rule is, you know, if your bias light is cool, like if it has a lot of the blue component, this blue then will be missing in your image, meaning that it looks like your TV's picture is too warm. And if the color behind the TV is too warm, meaning it has a lot of red component, it looks like the TV is missing this red component. So yeah, it is really important to match the color temperature, because otherwise you have the feeling that the white point is incorrect.
A couple questions in the chat room about this. Barfel asks, wouldn't the bias light be set for a quote-unquote normal maximum brightness, which would hardly ever be 1,000 nits? What leads to the 10% of the peak brightness number? Why is that important?
Because you want to see dark parts of the image. You want to be able to see details in the dark part of the image. And one thing that we need to be aware of is that in HDR, these 1,000 nit situations are not very frequent. We do have specular highlights. We do have small elements in the picture that could get up to 1,000 nit, but it's not the majority. So it wouldn't make sense to have a 1,000 nit backlight. You wouldn't see much detail in the dark parts of the image.
Yeah, I understand that. The notable exception might be if there was ever an HDR graded version of the movie The Art of Flight. Have you seen that? Which is about snow skiing, snowboarding.
Yeah, exactly. Okay, yeah.
Where much of the screen is white snow.
Yeah, like Winter Olympics or so.
Yeah, exactly. That also. Emily the Strange is asking, what about outside lights from windows? Are there different methods for dealing with ambient lighting or house lighting rather than windows bringing in daylight? Well, sure. I mean, certainly you could block off your windows, and that would probably be the best thing to do so that you have some control over the ambient light, right?
Exactly. Controlling the ambient light is the key. So reduce it as much as possible, but don't make it so dark that you don't find your way in your room.
Yeah, right. Exactly. Somebody else in the chat room didn't use my name in the message, so I'm not sure I'll be able to find it, but he said something about, oh, here it is, K-Lou. I'm a big fan of bias or indirect lighting. Watching TV in the dark is bad for the eyes. It certainly can make for eye strain and make you uncomfortable, so I do agree with that. Let us do a short recap of what we talked about last week for those of my audience who might not have seen last week. Let's not spend a lot of time on it, but basically I think I would start by saying that high dynamic range, or HDR, is still in its infancy, and there's a lot of stuff that has yet to be nailed down, isn't there?
Oh, yes. Oh, yes. Even experts are kind of confused right now because they see numbers where they don't believe their eyes, and, you know, they make measurements and things are unexpected. So yes.
hmm One of the things that strikes me as being fluid, shall we say, is this issue of peak luminance, which we've been talking about here with regard to bias lights. But just in terms of what the TV can do or what the mastering monitor can do, there are many. It's not standardized. Like in standard dynamic range, you have basically 100 nits of peak brightness, and that's what you master to, and that's what you watch when you're at home. But in high dynamic range, you might master at 4,000 nits, but you might only have a 1,000 nit or a 500 nit TV at home. So the difference in peak luminance, the variability, I guess I should say, of peak luminance is one of the big concerns, isn't it?
Oh yes, but see, light output is costly, meaning that you have to have very bright backlight. In this case, it's really the backlight.
The real backlight, yeah. Yes.
So you have to have a really bright backlight, which means very bright LED or a big number of LEDs consuming a lot of power, potentially creating heat. And then we have this issue of energy efficiency and all of that. So it's always like a trade-off. The better TVs, of course, they are able to deliver a higher brightness, but it's really costly. It's costly in terms of energy consumption. It's costly in terms of the amount of LED lights that you need to put in the back of the TV. And not to forget, if you have a very high light output, you have to have the contrast, the blacks under control as well.
Right. And what this leads to is more energy costs and a higher cost TV as well. Part of the way to deal with this issue of different amounts of peak brightness or peak luminance coming off of different TVs and different display monitors, broadcast and mastering monitors and so on, is something called tone mapping, which we talked about last week. And I don't want to get deeply into it here, but that requires the use of something called metadata, which tell us just briefly how metadata and tone mapping allow different TVs with different peak brightness to coexist.
Yeah, the big advantage of HDR, of the new HDR 10 system, for example, is that we have a big container, 2020 as a container, and up to 10,000 nits. And this container is capable of reproducing or of covering current color gamuts, including cedar gamuts like P3, and brightness levels up to 10,000 nits, which is nothing that a current TV could do. So we are prepared for the future. And of course, the professional devices like the production monitors, which are very expensive, we are talking about like $30,000 or so, they of course have higher brightness capabilities. And sometimes they have higher color gamut capabilities, meaning they can reproduce a bigger color space, more saturated colors, and these things. So there's a mismatch in between these professional production devices and the devices that we have at home. And this mismatch needs to be communicated. And this is what the metadata is for. The metadata is defining the situation that was existent in the mastering when the content was mastered. With this information, the TV knows, how do I remap? How do I interpret whatever comes in as an image to my own capabilities? So in general, coming out of a fixed system 709 with a fixed peak brightness, with a fixed color gamut and gamma, coming out of such a system, we're now leading to a system that is very, very flexible and prepared for the future, whatever that will be. We'll see bigger color gamuts, we'll see bigger brightness capabilities, and all these things are covered by metadata. So in order to make it flexible, we need the metadata about the mastering situation. It's all about knowing what the creative intent was all about.
Right. And then reproducing that as accurately as any given display will allow based upon its own capabilities.
Exactly. And that's what tone mapping is for. So for example, we have a mastering monitor with 4,000 nits. And this mastering monitor, this content that was mastered on this mastering monitor is ending up on an Ultra HD Blu-ray. And the TV that we're using at home is probably able of doing 800 nit. So we need to make sure to find a way of reproducing the areas of brightness within the capabilities of the TV. And that's what the tone mapping is essentially doing.
It's remapping what was seen on the 4,000 nit display to the 800 nit display and what it can do without a lot of clipping. That's one thing that we have to make sure everybody understands, is that if you just let the luminance go up to 800 nits and then from 800 to 4,000, the TV can't do it, so it's all just flat. That looks pretty bad.
Yeah, clipping means you're losing information. Clipping means your details in the highlights or in the shadows. Sometimes we have shadow clipping as well. Your details are getting lost. Like I can see it in the image here. The detail in my shirt is lost because of the high amount of brightness. Here you can see all the lines. There it's lost. So that's a situation that we can avoid with HDR and correct metadata.
Here, of course, what you're seeing in this image is standard dynamic range. So
exactly.
With no metadata, nothing at all. And I think that's a great example of using something that we're actually looking at right this minute. If we had metadata and HDR, then you would be able to see more detail in the bright part of your shirt.
Exactly.
Yeah. Great. Well, before we go on, I would like to take a moment to thank one of our sponsors for this episode, which is Corning. Now, Corning can greatly improve your audio-video workflow with their strong, durable, and far-reaching Thunderbolt and USB 3.0 fiber optic cables. Whether you're into high-end video, photography, audio production, or computing, Corning's optical cables will allow you to build a convenient workspace through a superior long-distance connection. Corning's USB 3.0 and Thunderbolt cables are incredibly strong and flexible. They have exceptional cable runs of up to 60 meters or 200 feet for Thunderbolt and 50 meters or 165 feet for USB 3, making it so easy to move your noisy, space-consuming devices away from your workspace. Corning's cables are also hot swappable, and you can daisy chain up to 6 Thunderbolt devices. You can bend or walk on Corning's ultra-slim cables, and even if they're tangled, they'll keep transmitting at top speed. Now, Universal Audio relies on optical cables by Corning to achieve acoustic isolation in their studio, where they test new equipment such as their best-selling Thunderbolt audio interfaces. And I know this company very well. It's a very well-respected brand in professional musical circles. So they know what they're doing, and I certainly trust them to use the best possible cables they can to do what they need to do and keep their equipment, their noisy equipment that they're using, away from the testing facility. Instead of investing on multiple extenders, adapters, and cables, turn to Corning to establish the connection you need with one simple long-length cable. Corning's products are available at all major electronics and professional AV retailers, including Apple stores, Amazon, B&H, and more. Corning's cables are longer, thinner, lighter, and stronger. Go to corning.com/twit to save up to $130 on Thunderbolt optical cables. This promotion is valid only from June 1st to July 31st, or while supplies last, whichever comes first. Just go to corning.com/twit to save on their unbeatable Thunderbolt cables. And we thank Corning very much for their support of Home Theater Geeks.
God, by the way,
yes?
I'm using a Corning cable.
Oh, no kidding! All right.
Yeah. And it's an optical Thunderbolt cable, and I was very skeptical because I needed a 10-meter run from one Thunderbolt device to another, and I needed a very fast speed. So we're speaking about a RAID device with it's a hard drive with 48 gigabytes and terabytes. I'm sorry.
Yeah.
And I'm transferring effectively 1 gigabyte, not gigabit, 1 gigabyte per second over one of these optical cables. So this is needed, for this 4K raw HDR video editing. You need very fast connections, and it works really well.
Wow. Hey, what do you know? An unsolicited testimonial. That's great. And you're exactly right. You're dealing with, even more than what a consumer has to deal with, because you're actually shooting content and moving it around. And so that kind of speed is critical. And you keep the RAID kind of away from your workspace with a 10-meter cable. And it works at top speed and does what you need it to do. That's fantastic. Thank you for mentioning that.
Welcome.
The other thing I wanted to just touch upon is, before we move on to new topics, is the EOTF, electro-optical transfer function, which, as we learned in the SMPTE webinar this morning that you and I were both on, afternoon for you, morning for me, is really the way in which, well, we already knew this, but it was said in this webinar, that the EOTF basically defines how a display will take in a code value in the signal that says, I need this pixel to be this bright, or it has a brightness number of X, whatever it is, and how will the display, how much light will the display output for that pixel based on that code. And that is the electro-optical transfer function. And the one that we've used up till now is called gamma, and we have a graphic of that, actually, number 1, that I wanted to show people. And that one here, we see something called the Barton ramp. You want to give us a clue about what this picture is telling us?
Interestingly, I don't see the full picture, but yeah, in general, the Barton ramp is about your perception. It's more about the perception of image of differences in brightness than it is about the curve itself. It's the theory is that specific differences in luminance are more obvious to the eye than others. So some of these luminance differences need to be represented by many values. Like we need a lot of values in the dark areas of the image, like up to 100 nit or so. And some need to be they don't need as many values. For example, we had this last time, 50 nit difference in the dark area of the image is very good to perceive, but 50 nits different in a bright part of the image, like 1,000 and 1,050 nits, is not so easy to perceive. Now, with the Barton ramp, we can see different ways of quantization. And this quantization, essentially what this tells us is that with a 10-bit word, we have
with
a chance.
A gamma curve.
Yeah, where is the
the red line? The red PQ is not on here yet. That's the next graphic.
I see.
This is just gamma right now. So I wanted to point out how gamma doesn't really do the job. We have this red line is a 10-bit gamma, and if anything above the dotted line in the red area, you're going to see banding. You're going to see the effect of quantization. So in this case, anything below, I think, 10 nits. As you say, the darker areas, people are more sensitive. Humans are more sensitive to changes in luminance. And with 10 bits, using what we know of the EOTF called gamma, you're going to see banding. You need 15-bit gamma in order to not see banding at any brightness range.
Yeah,
now,
especially In the higher areas of, at any brightness range, essentially, yes.
Yeah, exactly. The other problem with 15-bit gamma, though, is that it's very inefficient. In the higher brightness range, you don't need all that resolution because you're not going to see any banding anyway. But if we go to the next image, graphic 2, which is called PQ Barton, then we're going to see, there it is. We're going to see the advantage of PQ over even 15-bit gamma. Tell us about that a little bit.
Well, some people might be confused by 15-bit gamma. 15-bit is not really exist. These are
it doesn't
all
exist. No. Yeah, this is theoretical. Yeah,
this is theoretical.
Thank you. Yes,
but essentially, what we're learning out of this, we would need 16-bit in order to stay below the threshold of differences that we would find that of banding. Let's say we would need 16-bit linear to stay below the threshold of banding. That's a very simplified way of putting it, but that's essentially how it works. And because we don't have these 16 bits available right now, because we don't encode in 16-bit, we don't transmit in 16-bit, we need to find a way of working with the 8 or 10-bit that we have available. For HDR, we really need 10-bit. And that's what's available in the consumer world. Of course, some of the professionals are looking for at least 12-bit. We heard that today in the SMPTE presentation.
Yep.
But you made a good point of, is it available in the consumer devices? Most likely not. Even Dolby Vision is 12-bit, mainly, full 12-bit. You'll see it in the professional applications like theater, and I haven't seen any 12-bit, real 12-bit device so far in the consumer world.
Right, exactly. But this EOTF that Dolby has developed and is now a SMPTE standard called PQ, for perceptual quantizer, takes into account this Barton ramp, this curve that we just saw, that defines where humans can typically see banding and where they can't. And as long as you stay below that curve, then you're fine. And 12-bit PQ, which is what Dolby Vision uses, it stays below the curve all the way from the darkest to the brightest. And so we don't see any banding anywhere in any image if we follow that 12-bit PQ curve. Unfortunately, as you say, consumer devices are 10-bit, and that raises that PQ curve somewhat. Although I think Dolby has some way of kind of reducing from 12-bit to 10-bit, but still retain more of the 12-bit characteristic. I'm not so sure about that. Do you know anything more about that?
In order to make a valid statement there, I would like to see 12-bit test patterns encoded in Dolby Vision.
Okay.
You see, the reality that I see is that not all of the HDR10 and Dolby Vision devices even do 10-bit. So because of you have some video processing going on in the TV, and potentially your video processing is not oversampling, your video processing doesn't have a bigger bit depth than the 10-bit, you'll see quantization errors, and therefore you have maybe like 9-bit or so,
Yeah, that's true. A good point.
And I don't see 12-bit in the consumer world yet. None of the devices, I haven't seen it.
Yeah, no, nor have I. And I don't think we will for several years. So we still have this issue of quantization error and banding that might come up, particularly in low brightness, low dark kinds of scenes. Just wanted to put that out there.
I'm not exactly sure. I've seen it more obvious in mid to bright areas of the image.
Oh,
Quite
really?
honestly.
Oh, no kidding.
Yeah. So for HDR, you need to see. I mean, we have a lot of dynamic range in the image, and HDR is all about conveying a high amount of dynamic range in the image, and we have 50% of all values in PQ spent for the area between 0 and 100 nit. And that means in a 10-bit world, we actually have a lot of values. And you don't see so much banding there.
I see. Okay. All right. But the other 50% goes from 100 nits to 10,000 nits.
Yeah, it's like from 50 IRE to 75 IRE, we're representing the area between 100 and 1,000 nit. And then the next 25% or IRE of the image are representing 1,000 to 10,000 nit. So when we are working with the HDR10 system and 1,000 nit, we're effectively using 75 IRE of the original signal.
And that's really 75% of the maximum brightness, which in the case of PQ is 10,000 nits. IRE is kind of an older term. I forget what it stands for. Do you remember? International something or another, probably. But that's a very old term.
Thank you.
Not that you're really old, of course.
No, I mean, it's essentially the percentage of the signal. If you go, it's normalized. So we have a legal range, and it's the normalized value within the range, whatever you use. So for example, in 8-bit, we knew that we had 16 to 235 as a legal range. Now it is called narrow range from 64 to 960, and 50 IRE would be, in the middle of this range. So it's like a percentage. It's fine to say it's a percentage.
Yeah. The other thing I wanted to just bring up a little bit here is color gamuts and primaries, and I want to take a look at graphic number 3, which shows us the 3 sort of ranges of color or gamuts that we are talking about here. The smallest one, the yellow triangle, is what we now use in HDTV. It's called 709. The middle triangle is called P3, and that's what they use in digital cinemas, and what we are now probably going to be using more or less for Ultra HD and high dynamic range. And the biggest triangle is called 2020. And that is the one that we talked about last week as being not only a set of 3 primaries, but also a container for the smaller ones, right?
Yes. So again, the big value, one of the big values in this new system of HDR is that we have a big container that is capable of covering the current HDTV standard, as well as the theater standard, which is P3. So what you see on a digital film projector in a theater is P3, and it's the production environment as well. So many post-production houses are actually working with P3, and they are now very happy that they don't need to change the colors, that they don't need to adapt the colors to something else. So P3 actually seems to make most sense, for content that is produced currently. It's also very close to the coordinates of analog film. So P3 it really makes a lot of sense for a motion picture.
Now, a lot of people have said, well, okay, we're going to go with P3 for now, but what we really want is a display that can do 2020, that can do that biggest triangle, that can reproduce all the colors within that biggest triangle. But that's a problem, isn't it? There are some problems with doing that.
Yes, several ones. One is the individual perception. So your photoreceptors in your eyes are highly individual in terms of the spectral response. And this spectral response is triggered differently if we have a single wavelength that is, triggering our cones in the eyes, and that is known as metamerism. So the problem with that is if we have single wavelength primaries, the individual visual perception in between different viewers will be different. So that's not a situation we're looking for. The bigger benefit of this big color gamut is that we're able to cover, P3 and everything in between up to 2020, and maybe we will go to something that is close to 2020. Actually, something that is bigger than P3 makes sense for calibration as well, because as soon as you have something that is slightly bigger, you are in a position to color correct your color gamut to a point where it's exactly matching the target coordinates. And that's something that helps.
Got it. In fact, that's our next topic of conversation is calibrating and some of the issues there. Before we get to it, though, I'd like to thank our sponsor for this episode, which is Epson. Now, Epson's revolutionary cartridge-free EcoTank line of printers for home and office introduce a new age in printing. The Epson EcoTank ET4550 wireless all-in-one printer doesn't use ink cartridges. It features an amazing, innovative, refillable ink tank, earning it the title of CES 2016 Innovation Awards honoree. No more out-of-ink frustration. It includes up to 2 years of ink, equal to 11,000 black pages or 8,500 color pages. You can save up to 80% on ink with low-cost replacement bottles. It's also powered by Precision Core printing technology, and it has auto two-sided printing and a 30-page auto document feeder with easy wireless printing from tablets and smartphones. All EcoTank printers deliver an unbeatable combination of convenience and value. With Epson's EcoTank line of printers, you'll have the freedom to print without running out of ink. The Epson EcoTank system, in fact, was named the 2016 Small Biz Windows Printer of the Year. So visit epson.com/ecotank today to transform the way your home, office, or work group prints. For the best combination of ease and value, turn to the Epson EcoTank printers. That's epson.com/ecotank. And we thank Epson very much for their support of Home Theater Geeks. Epson, exceed your vision. So I'm talking with Florian Friedrich about HDR, high dynamic range. And one of the big problems, we've been talking about, how it's in its infancy, and there are a lot of unknowns and variables, and who knows what the heck's going on here. And one of those problems is, in fact, calibration. How do we calibrate a TV, a monitor, to reproduce what the content creators have made as accurately as possible? And at the moment, that is still also somewhat in flux. There's a program that most of us use, those of us who review TVs and calibrate TVs, especially consumer TVs, but it also works on professional monitors, called CalMan from SpectraCal. And I've had the guys on from SpectraCal a number of times on the show to talk about various things, and they'll come on again, I'm sure, to talk about this. But Florian, I wanted to ask you about where CalMan is at this point from your perspective.
As the whole system, it's in the beginning.
It's in the very beginning. Yeah, okay. Let's get a little more specific. For example, in the current version of CalMan, there is something called the golden reference, which applies to Dolby TVs, Dolby Vision capable TVs, I mean. And really that only applies at the moment to, I believe, the Vizio reference series. I don't think they have a P series golden reference yet, but tell us what the golden reference is and what its purpose is.
Yeah, so I can't talk about the purpose, because I haven't designed the system.
Yeah, okay, all right. Fair enough.
However, when I heard golden reference at the first time, I was thinking about the mastering environment, because for me, the golden reference is the mastering situation. The situation that you have while you're in the post-production, the situation that you have while you're producing the content. That should be the golden reference. However, what it is in this case of calibrating HDR or Dolby Vision with Kalman is the capability of the TV in regards of the color gamut. So we're actually deviating from the mastering environment, and our targets are now exactly matching what the ideal color gamut coordinates for the specific TV should be, and that's of course a decision by the manufacturer. It's like the capability of the TV is baked in to this golden reference, and I don't accept this for doing evaluation work. It is good to do some calibration work. It is good to make the TV match to its own standard in order to have like 10 TVs looking the same. In terms of Dolby Vision, it seems to make sense because the tone mapping is based on this golden reference standard, which means there is a specific tone mapping for every TV. And of course, part of doing the tone mapping correctly is knowing the capability of the display device. So this whole golden reference thing makes a lot of sense when you're trying to have a standardized tone mapping. But it doesn't make sense when you're trying to evaluate the accuracy of the TV in general. So there are different settings in Kalman that you could use in order to decide whether you want to do a calibration or you want to do an evaluation. So I have compiled a set of images where you can see these differences. So we have what we see here is 1, 2, 3. 1 is a representation of Rec 2020 with color saturation ramps, and 2 is P3, obviously a little bit smaller, with the same color saturation ramps coming from a white coordinate in the center to the individual primary and secondary colors in the color in the CIE 1931 diagram.
Right.
In case of the golden reference, it's number 3. We will see that the green coordinate, if we compare it to number 2, maybe we have both of the images right next to each other. The green coordinate is not as close to the corner of the sail. Is that appropriate to say?
Sure.
Is not as close to the sail as it is with the P3 standard, which is our production standard. So what we can see there is that the golden reference standard, the standard for the device, is a different one than what the mastering situation is. So again, in my opinion, for evaluation, the goal should be to compare it to the original content. So the golden reference is the mastering environment. And
should be anyway, but it's not currently.
Yes. So it is important. By the way, it is important to select the color gamut that is identical to the content. Meaning, if you're using an Ultra HD Blu-ray, it's most likely D65 and P3. There are tools to find out what a specific Blu-ray is actually using in terms of maximum luminance and color gamut. So you could use the HD Fury and the AV Top controller to read the HDR info frame and see the values. However, the most common situation is P3 and 1000 nit as a mastering situation. And there's only a second one right now that's 4,000 nit. So we have 1,000 and 4,000 nit, but most likely the HDR UHD Blu-rays are P3 and D65. So you could use
and 1,000 nit.
And 1,000 or 4,000 nit.
Yeah.
So you could, starting off with a 1,000 nit P3 D65 situation for evaluation is a very good idea. And even this 1,000 nit needs to be defined. I have a second screenshot for the selection of nits.
Right, and that's number 5, as I said.
And so it's a simulated meter, and what we see on the left-hand side is a number of delta E values in the grayscale that we're measuring.
And those delta E values are very high. Delta E I've taken normally to mean error. So the higher the level, the higher the value, the worse the error is. Exactly.
In this case, our simulated meter was a SDR meter, and it's very clear that if you're using SDR values and try to find out, how accurate your HDR is, the delta E values will be pretty high. But one thing that we can see is that on the top of these images, on the top one at 100 on the left side, the delta E number is very low. So it is a little bit strange then that when you're measuring HDR and when you're measuring 100 nit as a peak luminance, there is a low delta E value.
It's very accurate.
It shouldn't be accurate because your peak luminance in PQ shouldn't be 100 nit. It should be 1,000 nit according to the mastering situation. So actually the number should be very high. Now, what's the reason for this low number? And we see that if we go to the right-hand side of the diagram, the reason is that we have defined, it's the standard setting in the workflow. We have defined a target white as being the measured white level of the TV, which is, in my opinion, a little bit strange because you want to follow the PQ curve as long as possible. And let's say your TV cannot do 1,000 nit, but maybe 800 nit. You might want to follow the PQ curve up to 500 or 600 nit. And
I think I see what you're saying here, that what you're doing here, what this is doing is relative to the maximum luminance of the display, whereas PQ is tied to absolute luminance values, not relative.
Exactly. Okay. So, there are always decisions why you want to make it relative to the device capability. Most likely if you're reviewing an OLED device that cannot do, and if you're using maybe a full frame, a full white, like a full white window, then your restriction might be 150 nits for full white. So it cannot do 1,000 nits at all, and you would measure very high delta E values.
Yeah.
However, I think it's fair. It's always the question of, do I want to follow a device standard or a mastering standard? And we need to be aware of these settings. And in my opinion, I'm using the 1,000 nit mastering situation in P3. So my golden reference is not anything that is defined by the device. My golden reference is something that is defined by the data, by the movie. That should be the reference in my opinion.
An interesting position, and one that I hope a lot of people listen to, because it makes a lot of sense to me. Let me ask you about metadata. We've been talking about this now over the 2 shows, and I want to talk about static versus dynamic metadata. HDR10, which is one of the two main standards that we use for HDR. Both of these standards use the PQ curve, but HDR10 uses something called static metadata, which basically is the same metadata over the entire program, say an entire 2-hour movie. Whereas Dolby Vision uses something called dynamic metadata, which can change from one scene to the next. Have I got that right?
Well, even HDR10 is capable of dynamic metadata.
I didn't realize that.
So yeah, I heard that very often. Like only Dolby Vision can handle dynamic metadata, but it's essentially not true. It's in Dolby Vision has some strategies, in order to tone map and according to dynamic metadata, but HDR can do the same thing, and that's defined in SMPTE 2094, or it's being defined in SMPTE 2094.
Yeah. As we learned today, that is another standard that is in process of being finalized. It's not done yet.
Exactly, and it's going to be a very powerful environment. So, in general, I mean, it starts with the fact that program material might come from different sources. Like you could have HDR material from production A and HDR material from production B, and in both situations you would have different mastering environments. So and then you want to intercut the scenes and you want to change the metadata accordingly. And another situation is that you have very limited capabilities of the TV and want to make decisions on how does the tone mapping happen in an ideal way. So both situations need dynamic tone mapping to some extent, and the SMPTE standards that are in progress right now are defining a lot of different possibilities to work with this dynamic metadata. It could be a 3D lookup table, but that's maybe too much to explain right now. A lot of things can be done based on dynamic metadata in a video signal, and it's not restricted to one system or another. Basically, we need it to happen in HDR as well as we need it in Dolby Vision.
I saw an interesting demo. I don't know if you saw this at NAB last April. Samsung had a demonstration of static metadata, or static tone mapping, I should say, versus dynamic tone mapping, and side by side. And the difference was not subtle. I mean, it was really, you could really see the advantage of doing dynamic metadata based upon one scene was mostly dark with a bright fire. Another scene was much brighter, and they looked a lot better.
Yeah, there's a set of people that is very happy about all this metadata, and there's another set of people who are very concerned, and that I think leads us to hybrid lock gamma, because with hybrid lock gamma came up as alternative for a high dynamic range without metadata, where it's not so important to carry the metadata along, because broadcasters were concerned about the fact that metadata could get lost on the production, within the production. So especially in live events and so on, it makes a lot of sense to have an alternative system, and that actually was defined in 2100, which we started to discuss about last time. So the 2100 ITU standard holds HDR10 or HDR and HLG.
HLG, hybrid log gamma, which is this thing, EOTF, developed by BBC and NHK, British and Japanese television. And as you say, it doesn't use metadata. Now, in the SMPTE webinar we both attended this morning, they mentioned that, and it looked to me like it was more aimed at broadcast rather than packaged content. Is that true?
Yeah, it is true because some of that is true.
Good. Well, that's why you're here to explain it.
So it is more important for live content, yes. And in fact, it's not standardized on Ultra HD Blu-ray at this point of time. So when we have HDR on Ultra HD Blu-ray, it's going to be HDR, not HLG. However, it's not working without any metadata. I do have this tool of SEI edit, and you need, in order to trigger the TV to get into the HLG mode, you need to add the metadata. However, the big difference is that even without interpreting this kind of metadata, you will see an image that doesn't look too flat. So it is an image that looks good. And it's not distorted like a HDR image that you would look at without any sort of metadata. That's the story. You need the metadata, but it's not so super super bad critical.
Yeah, super
if you lose.
Okay, yeah. All right, all right. Now, I think, is this the point where the two screenshots you sent me today would come in
for the SEI edit?
Yeah,
of course.
Okay, so let's look at number 7 and let's look at number 7 first, and then 8 following.
Yeah, so this tool SEI edit is a tool that I have produced that is actually adding metadata to HEVC files. Okay, so you're using a HEVC file and you're adding metadata to it. It's being used by post-production houses and manufacturers, and just recently, just today actually, I've released a new version of it with the HLG function in it. So you could create HEVC HLG files with it.
Wow, that's pretty cool.
Yeah, so it's cool for testing the TV. It's cool for creating content, and basically these tools I started to create them because I needed something for my own work. And
as it always is, right? You build something because you need it for yourself, and then you find that other people need it too.
Exactly. And then you start selling it, and eventually someone will buy it.
Yes. Now let me ask you this about HLG, hybrid log gamma. If you embed that metadata that just tells the TV that what's coming is HLG, will any HDR capable TV be able to deal with it? As it is now, you have some TVs that can respond to HDR10, but not Dolby Vision. In some cases, you have TVs that can respond to Dolby Vision, but not HDR10. Is HLG kind of a more universal thing that all the TVs will be able to respond to?
Yeah, see, the thing there is, even if the TV doesn't respond, the picture still looks good. So that's the whole concept. I don't think that we will see less issues than we have seen for HDR10. Actually, the media players of the current TVs, no matter what manufacturer, are pretty good. I mean, the TVs are reacting to these sets of metadata in a way where you could say it works. You can put a HEVC file with a HDR metadata into the thumb drive, onto a thumb drive, and stick it into the TV, or stick it into an Ultra HD Blu-ray player, and most likely it will work. But there are these legacy TVs, like you might have a media player that cannot do HDR. You might have a standard definition TV that cannot do HDR. So in this case, what do? It doesn't help to have a file that is incompatible, is looking flat and desaturated. So HLG helps a little bit with this, but quite honestly, you need a very new TV anyway, because all of this is encoded to HEVC 10-bit, and the only the better TVs, only the most current TVs can deal with this. So it's not like, yeah, we now have HLG and it will work with all the old TVs, and you don't see the dynamic range that you would see with TV that is compatible, and you would potentially not be able to play it because the TV cannot play 10-bit and maybe doesn't even play UHD. I've seen UHD TVs that have a media player, but the media player is not capable of UHD.
What?
Yeah.
Well, there's one other graphic I want to make sure we show, and that's number 8, which I think is an example of what you were just talking about. So tell us what we're looking at here.
Yeah, this is actually a still picture of a video file that is available for free download if you go to Quality TV or the homepage of seiedit.com. It is a video file that can be used. It's 10-bit HEVC. It can be used for applying different sets of metadata. And, it's just moving clouds and gray rams and color bars, top and bottom. It's full range in this case. And applying different sets of metadata, you will see if the TV is responding to it. The free files that are available for download will allow you to just check if your TV and media player is capable of playing HDR. So just download it and see if your TV is responding to it. In the HDR version, you should see more saturated colors. You should see the higher areas of the brightness clipping, because it's a 1000 nit mastering environment. So it should only show luminance levels up to 75 IRE. But you basically will see differences in between the video files. And it's 60 frames per second, by the way. It's UHD and 60 frames per second.
Cool. And you can get that where again?
You just go to seiedit.com. It will lead to hdr.avtop. But go to seiedit and then there's a download button.
Okay, cool. One last question. You mentioned you knew that Joe Kane's been on the show a number of times, and you're working with Joe on a variety of projects. And I want to get you and Joe back onto the show together to talk about that when you're ready to. In the meantime, though, I think you remember that last time Joe was on the show, he said that he thought maybe SDR with 10-bit resolution was plenty good, and maybe we don't even need HDR. What is your response to that?
My response is it depends.
A very good answer.
So if we have a situation where our original content doesn't have a lot of dynamic range, where we don't have specular highlights that are very bright compared to the rest of the screen, then yes, SDR 10-bit makes a lot of sense. And we could even think about SDR 10-bit P3, but as soon as we want to represent a bigger dynamic range, and as soon as we have a source where we are in a position to potentially have a high dynamic range and therefore a bigger realism, depth impression in the image, then we should go to HDR, because HDR is much more efficient when it comes to representing a higher native contrast ratio in the image. You're losing way too many values in encoding high dynamic range images into SDR. That's inefficient, very inefficient. So we really need HDR for these situations where we have good content, even film scans that are done well. Film scans are now being done at 16-bit depth and 6K resolution. So many of the old movies that were there even decades ago captured a bigger dynamic range, and I'm looking forward to see this very high amount of dynamic range and bigger realism. Again, the biggest part is specular highlights and direct light, like the sun. In SDR, it looks not realistic. So it is a clear breakthrough for HDR to represent a bigger dynamic range.
Mm-hmm. And make the image look more like reality.
Yeah, and even in the darker parts, if you have a high dynamic range in the original image, the darker parts will look less noisy. The darker parts of the image will look more clean.
Mm-hmm. And you can see more detail in them, even if there's bright areas elsewhere in the same image.
Yep.
Yep. Well, listen, we've come to the end of another hour, and I want to thank you so much for being here and staying up so late and helping us understand HDR, which is a brave new world. I'm sure we're going to talk about it again, and I would love to have you come back with Joe and tell us about the project you're working on.
Thank you. I'm still trying to understand all aspects of HDR. It is... See, there are so many aspects and so many new developments. So it's a learning process for everyone. So no one needs to be shy in terms of I don't know this or that about HDR. It's a learning process for everyone.
Yeah, exactly right. And for me too, and for all of the HTG, yet more alphabet soup, Home Theater Geeks viewers as well. And I hope that you out there who are watching and listening to the show have been able to gain some understanding about this very complex but very interesting subject. That's Florian Friedrich. His main website is quality.tv. Also go to seiedit.com for that free video download and more about Florian's work there. You can find me at avsforum.com. You can follow me on Twitter at htgeekscott or at AVS Forum. And you can email me at scott@twit.tv. You can always find previous episodes of Home Theater Geeks right here at twit.tv/HTG and on our YouTube channel, youtube.com/twit Home Theater Geeks. Next week, my guest geek is scheduled to be Academy Award-winning sound editor and sound designer Lon Bender. He was on the show once about 4 years ago, but he's come a long way since then, and I'm sure looking forward to talking with him about his work in sound design and sound editing, and I do hope you will join me for that. Until then, geek out.